So this is going to be 2 presentations. I'm going to go for about 15, 20 minutes or so, and then we're going to swap over to Wiebe, who's got some more impressive demos and a full-fledged application he's going to be showing off. So I'm going to try and zip through my object-oriented UI panels discussion, show some demos, and then we're going to take an awkward 2 minutes to swap over to Wiebe's computer. So I'm Derick Bommarito. I've worked for a couple of alliance partners since 2012, and now I'm directly working for Halliburton as an internal developer, working on all the stuff that I was writing since I first learned LabVIEW. So I don't get to curse anybody else out but myself. It's a really interesting situation. What we're going to be talking about, I'm going to start off with a demo, hopefully pique your curiosity, and then we'll talk about how I do it. This does build on how I do by reference classes. If any of you saw the presentation yesterday that I gave, I used VI Server just a little bit to kind of fake dynamic dispatch to get the user interface panels managed. One of the things the main thing that I created this for was to create custom arrays where each element of the array could be a different user interface panel. No problem. So for this first demo, this does pretty much what it looks like the MGI panel library does. I've got 2 subpanels here that I can use. Each one of these panels is a different class in my project. I've got panel A and panel B. They each have their user interface. So if I need multiple copies of these, I just instantiate multiple copies of them, and I can have as many as I want in an application. I can swap these back and forth. I can pop them out as pop-ups, close them, put them back in. One of the utilities I have is one of these guys, I didn't turn on block diagram, open. One of these guys only counts while it's visible. The other one is always counting. If we go ahead, take a quick look at this. I've got a panel manager instance that I'm creating, references for my subpanels, my 2 subpanels my 2 panel classes that I instantiate, and then for the different events that happen, I've got a VI that I call on the manager to perform some action on that panel for me. So anybody here have any idea or any questions as to what you can do with OOP and why we would want to try to do this? Okay. One of the things is I do use the settings in the class setting in the base panel class to enforce that you have to have certain methods implemented to make some of these features work. This builds on my by reference classes to make it easy to get data in and out of those user interface panels. And this guy right here is what makes it work. These VI server calls. So to make it a little bit more flexible and allow somebody to change the name of the class control that's on the front panel of the user interface, I basically just crawl all of the controls on the front panel but find the control that matches the class type of the runtime type of the class that it's working with. I'm programmatically building the name of the VI so that we can open a reference to it and then run it asynchronously. At that point, it then makes the reference for that front panel available, for that VI available, and the panel manager can push it around to wherever it needs it. This is what the code would look like on one of those user interface panels. Typically, they're always going to have some kind of user interaction. The important thing that my library needs to work properly to maintain state is we do have some VIs that handshake back to the manager class so it knows when it's ready to start receiving events and when it's safe to go ahead and clean the references up. So The manager for the demo we just saw looks like this in the project. We've got, for each of those actions we can do with a panel, we've just got a VI for it. The manager is what everything happens through the manager for keeping track of which subpanel a panel might be in or what its state is. So the panel code that you write doesn't have to maintain that state itself. The other thing I do is I've got another manager class that allows me to use these panel instances in an array, in a fake array view, which is really good for doing things like recipe editors, where you might have different step types. Each different step type can have a different display. So we're going to go ahead and take a look at that demo. So I pre-populated this before, well, half of you were sitting here watching me do that. But this is just 6 subpanels and a scroll bar, and I pass those references into the array manager, and it gives me some nice features. I can move stuff around. We can see the preview updating here. So we can see some of the different step types, just a static set point. There's barely see the steps that are in this one, and then we've got smooth temperature ramps. So this would be used to like schedule temperature set points for an oven. I can add new steps, and it just adds them to the end. I can remove steps out. No, that is 6 subpanels. So we'll take a look at that here. So I've got 6 subpanels here. Just because I'm building this interface to be this size, if I needed more, I just plop down some more subpanels, add them into the array. So how this works is I've got my panel array manager constructor function here. I'm passing in the references of everything it needs to interact with, and then it spawns a background, an asynchronous VI to manage all the events for those guys for me. When we're creating a new step, I've got my little UI here to just have provide an enumeration of what type of step the user wants to add, and then we create our new step. So I've got a sub VI here that, given a step type, spits out which class type provides that function, that information. Instantiate the panel. If you do its call its constructor function. These do inherit, all of these step types inherit from a middle recipe step class. So that middle layer allows me to provide the same interfacing between my main application and the panels. There's some handshaking events, and the panels, when I click the remove button, instead of them removing themselves directly from the panel manager, it sends an event back to the main loop, which then calls the functionality to remove that panel and clean it up. Run the panel, add the panel to the array manager, and then we fire the user event for the main UI to initiate redrawing the graph. So if you need more positions in the array, you can just, there is also a decoration in the back to actually make it look like the backdrop of a normal array. But I could create references for these. And I just add that to the array, and I would then get a 7th position that could display recipe steps. Another little bit larger demo of what I did in the first one. This is an actual user interface for one of the control systems we have. Let's see, I've got some valves here that the user operates. But I can go ahead and swap panels around, move stuff, pop it out if I want to move something over to the second monitor. Apparently I've got a bug, it's not closing. This isn't deployed yet, it's still in development. But we can go ahead and pop out any of these small displays, move them around. Those ones close. But so this is actually something I use in the real world. And okay.
So each of your recipe classes, they have a VI that was.
Oh yeah, let's
show
look at
them now. Do we do that?
the.
It looks like there was some common functionality, like the up and down arrow.
Mm-hmm.
So I guess you have to build that into each one.
Yes.
And then
So which one is that? So step panels, this is the intermediate recipe step class, which just keeps track of those communication events for me.
I suppose you could build one that had all of that and then inherit from that and serve it into a sub-panel on it.
Yeah, I don't want to. I do enough abstraction as it is. I don't need to.
But, seriously, that's what the MGI takes care of with the tier 10.
Okay.
The inheritance tree allows you to have certain UI in the different abstractions.
Okay. Yeah.
Yes, and that's a big.
I'd be really. I'm gonna have to check it. Like I said, I only learned about that half an hour ago. I'm really curious to start using that and pair it with this array functionality. I think that would be really slick, or just add the array functionality into his. But yeah, so these do have, each one of these panels has events for the up and down. I could make a sub-VI that is on the recipe step class that could programmatically register for the events for those buttons, and I just have to pass references in. So I can make it a little bit easier that way, but it's simple enough that I wasn't too worried about it. On some of the bigger stuff that isn't a nice simple example like this, I'll look into doing stuff like that. One of the nice things that this lets me do is I've got my base recipe step that specifies the build preview VI, which is what the main application uses, and then each of the step types just has the code to generate the plot data for previewing that step type. So it saves a little bit of work. In traditional LabVIEW, typically we have some big state machine that knows about all the step types and has to, you've got one big state machine that goes through. Here I can separate the logic for what the different steps do in the different classes. This is another example that uses this. So some of the other features that this panel array manager does is you can see that some of these have some different vertical spacing. So if you enable the dynamic sizing option, it does resize the containers as necessary. You can have a VI in the panel class which says how much space it needs to take up. So there's a bunch of extra subpanels in here that it can move around and hide and show when it needs to, when there's more content on. This is right now available on GitHub. If anybody's curious playing with it, I'd love feedback. I'm definitely probably going to make some changes in light of hearing about MGI's panel library. Definitely need to check that out, maybe steal some ideas or add some functionality to his. Eventually I will be putting some tutorials and demos of this up on YouTube as well. And on that note, I'm going to pass it over to Wiebe.
Question first.
Oh yes, sorry, yeah. Anybody have any questions for a couple minutes?
Because you use an array of subpanels, does that mean you can pass different clusters into your steps?
I'm not sure. Given
So if you pull up your screen, all the elements in your array were the same cluster.
no, so in the editor UI, I'm passing in, these are just subpanel references.
Right.
So this is just the containers that those panels get displayed in. The panels are different classes. There's these 4 classes that I'm creating.
Then the question is, you can't put a different cluster into that subpanel.
Yeah, these panels have their own class definitions. They've got their own data that they keep track of. So that's in each position of that simulated array can be something completely different. They just have to inherit from the library's base panel class, implement a couple of functions that are required for override, and then they'll work with this array manager. And then they define the view and the data that they work with. Yes?
Clarify what he's asking. You're not really putting clusters into the sub-panel. You're putting a UI or a
Correct.
front panel into the sub-panel. So whatever's on that sub-panel shows up. It could be any cluster.
Yeah, you can mix controls, indicators. It's these, each one of these classes defines a panel.vi. And so these are the panels that are being cloned, and they keep track of the class reference they belong to.
In your example, all the front panels look the same, but they don't have to be the same. They could have different.
Some of them are a little bit different. Pretty much all of them. The colors, I used color to define show which ones were different. They're not clusters. These are VI front panels. You can't have, mixed mode controls and indicators in clusters.
If you wanted to add another control to one of those front panels, you could.
Yeah. There's nothing. They're regular VIs. They get to do all their functionality for maintaining their state for that class. One thing you could do if you wanted to do more of an MVC, you could have a different class that represents the data, and then this would just store that and work on that class instead of keeping track of the data itself.
In that block diagram here, that you have use the bulk as part of, like on the.
What's not propagating across the
So that is the panel class. I only pass that out when we close.
Oh, but it's the same one coming in every time. So
Yeah. So all the stuff I'm doing is I have a DVR hidden in the class, so I don't have to cycle it around.
Okay, because the next event is the one that you
Yeah. So I only need to pass it out here. If we look inside, well, that's not.
And it's not a shift register, so you're not putting something back into that wire.
So this is using, so, like I said in the beginning, this builds on my by reference architectures patterns that I use. So the class wire just has a DVR reference in it, so I don't need to keep cycling around. It's what lets me share. So like this, I should probably show the update code. We're just, from the panel array manager, I'm letting it keep track of all of the instances that I've created, so I don't have to keep track of copies as well. I get all of them backed out, iterate across them, and it's going to give them back as the base panel class that it knows about, so I just pass them back up to my intermediate recipe step class, and I call that build preview, get all the data out. Because they're by reference, I don't have other mechanisms that I need to implement to shuffle the data around. No, by reference is not. Any other questions?
Yeah, you said that there is another loop that manage the event in the background.
Yes.
I see only one loop. I don't see any that is transfer.
So in my initialization VI for my panel array manager, there's this sub VI right here, which then launches using asynchronous start this VI, which has events for the scroll bar, for moving things around. One of the things this does is every position that the scroll bar changes creates a new event. So instead of in the scroll bar value change event, I mark that we want to do an update, and then in the timeout is when we actually do the layout and figuring out which panels go in which sub-panels, and it moves everything around based on the size of the the position of the scroll bar. As you add more elements, it will stretch the page size of the bar as well. So this is the loop that's running in the background to manage the events for that manager. Yeah.
One more question. Do you have any decision-making capabilities, like after a particular step, oh, I want to jump somewhere else based upon the results?
Well, that would be up to the panels you create.
Yeah.
I mean, I could make a step that has a conditional in it, and then this is just an editor. You know, I could take the data out of these elements, put that in, you know, some INI file or something, and then I would have an execution engine somewhere else that uses that data to actually run it. That's where I would have that logic.
Okay, so that would there be some handshaking between those two threads there.
Yeah, I mean, this is just so an operator can have a better user experience for coming up with temperature recipes. If we wanted to view that data as well, I mean, I would use the same mechanism to read display the recipe in the other, you know, whatever's actually running it. All right, I think we're ready for Wiebe.
This works all right? Yeah? Oh, that's cool because usually you wear yourself. Okay. Well, thanks for showing up. I have seen Thursday mornings where there are no people, so everything is black here, so you don't see anything. Yeah, so, and I asked me to put these in. This presentation could be useful for badges if you want them. You should want them, of course. They're great. I have a few. I don't know what to do with them, but put them in your signature. Yeah, so I'm going to give a short introduction and then start with scaling VI that scales anything, and then scale up to a class hierarchy. Show how to add some interaction, and then how to decouple. So if you're not going to use this library, you can still use the techniques I used on object orientation, and maybe learn something from that, because Paul Morris also used it for his overlay class. If you see his previous presentation, it's the same pattern, so it's a useful pattern to learn. And it's very versatile, so you can use that everywhere. It's a really good pattern to know. If you have questions, you can just raise your hands during the presentation. If it's too many, then we won't make it at the end. But, we'll see. So I am Wiebe Walstra. I have been programming for 30 years, I think, but I started when I was 12. No, 42, no, more or less. And LabVIEW for the past 21 years, I think. So what do I consider dynamic scaling? Dynamic scaling basically deals with the scaling of objects when your front panel changes or your panel sizes change. This library I also needed because I wanted dynamic paints. So LabVIEW doesn't allow you to remove paints. You can shift them to the left or to the right. But my customer wanted any number of paints between 2 or 80. Also different arrangements. So the LabVIEW built-in message just didn't suffice. So this is not a product, it's not finished, it's not that polished. I have standards, but it's not, there hasn't been any code reviews or things like that, but I think it's pretty decent code. The code is working for me, it's flexible, it's available on GitHub, so the link will be at the end of the presentation. and this presentation will only show like 10% of the details. Hopefully the exciting stuff, the boring stuff I left out, because you can see it in the source code anyway if you want. So this is the application that required this library. Clicker, the test interface. So it's this application, and when it was like this, I managed to do it without dynamic or with the normal panes that are in LabVIEW. It was still a bit challenging because the labels, you want things to grow in the panels, but then the labels shouldn't grow vertically, so you already have a big problem. And then they started adding multiple graph types, stuff like that. This is actually also a non-destructive testing application, just like Paul Morris. So it's we use C scans, we use A scans, and phased arrays. That kind of stuff. It also, these are intensity graphs with overlays, just like Paul Morris's application. This has nothing to do with scaling, but it is cool. So I just show you. This is the whole point of the application, that it can do 3D visualization or representation of the scan data. Yeah, so there's theming, linky menus with icons, but you can still not do in LabVIEW. Yep. And this customer lets me make this kind of stuff and then put it on the internet and do presentations about it. So that's a good customer. Usually they say we pay for it, so we own it. But yeah. So let's start with the scaling VI. Making a VI that scales anything or everything in LabVIEW is a big problem because GObject position is read-write, but the bounds is read-only. So you have to, when you get a reference, cast it to specific types, and then you might forget types. And graphs, for instance, don't even have a bounds property. You can only change the plot array and then hope that the outside bounds of the plot hits. You can do that iteratively, but it's a pain. Yeah. But there is one feature in LabVIEW, and this is maybe hacking, but the LabVIEW executable is actually a DLL. It also has export functions. So if you put a function, call library function node on your diagram, you can actually type in LabVIEW, and then you get a list of functions here. This grow over the years from maybe 100 to 600 or so. It's a really extensive list. And LabVIEW uses those functions to do stuff. But we can also use that function, those functions to do stuff. This you have to guess the prototype, but yeah, you just keep guessing until it works. There's no hacking involved. It's, actually, this function is used by LabVIEW itself in the resize palette. So where you can select multiple decorations, for instance, and then say maximum, no, type in the width and the height, and that uses this function as well. It is a bit tricky because you don't set the size, but you set the delta x and the delta y. But that's very impractical, but you end up with a full library function node like this. And you can put it in a VI, and then you can scale pretty much everything. Subpanels are a bit tricky, and graphs are still a bit tricky, but you can put it all in a VI and handle that there. And you end up with a VI that scales everything. And that's very nice to have. So in object-oriented programming, I try to separate the specifics for a class from the function, because we're going to upsize this. So in the init we put the reference in the class, and then you call the resize and it gets the reference, and then we have a UML class like this. Very simple. But I want more, of course, because we are making something that scales flexibly. So what I use as an input of the VI is AX plus B, and that means I can linearly place the control anywhere in the rectangle that we specify over here. Right, so you say, in this case, it doesn't have any offsets, and it scales full size. That information ends up in the wire, along with the reference, and then the resize can use that information and resize how we want. I'll give a demo of that. Although it's pretty simple, but it's almost magical. So here I do in a for loop for control references and for scaling. I only use the A here, not the B. They default to 0 set. And then resize them to the bounds that I give them. And when I run this, I get this, for instance. And when I change the bounds, it simply scales the controls how I want. You can clap, yeah, sure. We can raise the bar a little bit. This is just the first one. Here we do add an offset. I put it on continuous run. We shouldn't do that, of course. But, yeah, you can do stuff like this. And this is more like what I needed in my application. And now we have a label that stays on top, and the graph scales vertically. Doesn't really like if you make it smaller than 0. It does handle that, but this example doesn't. Yep. So, yeah, I do defer panel updates. Yeah, that's why the VI has the VI reference section. Yeah. So it does use defer panel updates because that will speed things up quite a bit. So let's scale this up to an entire hierarchy. Because what I want is I want paints and I want question.
If you had like 100 of the buttons, would it update quickly still?
So the question is, would it update quickly if you put 100 buttons in there? Well, in my executable, I have like 60 graphs sometimes, and that works pretty decently. Yeah. I don't think the way I do it will slow things down significantly. So if you do have to scale them, I think you might as well do it like this. And I don't think it will be slower than doing it manually or yeah. So what we want is have dynamic paints and put the stuff in there, like this, for instance. And the way I do that object-oriented is by making a class that contains objects. So we use an init viewport to put the objects in there, and then a resize, just like the other one, but the resize now goes over the items that it has and calls the resize on all the objects. So the code would look something like this. Put some objects in an array and put them in the init over here. then over here called the resize. And the wire will have objects. If you're in it, it will have two objects, not an empty array. And that's very convenient. And we can extend that to a divider. So a viewport would basically have one rectangle and it places all the objects in that rectangle, but the divider would say I have a rectangle and I split it in half, and stuff is on the left pane and on the right pane, for instance. And it would look like this. So in this case I have a divider that splits two ways, and this will be on the first, on the left pane, and this on the right pane, or top and bottom. And I have a demo for that. So this is basically what was in the presentation. And well, that's not very exciting because it does exactly the same as the previous one, but in a different way. Here's the splitter example. It extends a little bit, two viewports, put them in the splitter. And that's also not too exciting because it just works. But this boolean is maybe exciting because I can actually click it and then get this. Of course, this is 50-50, but they have inputs to specify the ratio. That falls in the 90% details category. Now, from an object-oriented standpoint, it makes sense to give these three classes a common parent. And why is that? That is because they all work exactly the same, mostly. That they, from a user of these classes, they all do the same. And if you give them a parent, you can force them to be the same, and you can put common stuff that we will add later in the parent class. And you only have to load them at once. And then it will look like this. Of course, why wouldn't a splitter be able to contain a splitter or a viewport to viewport? So the way it is now with the viewport containing an object and the splitter containing a viewport, we can make that more flexible by saying a viewport can contain an object and a splitter can contain an object. And now a viewport can contain a splitter and a splitter can contain a viewport. And we have a very flexible layout. Next thing we notice is that the splitter and the viewport are mostly the same. In the sense that they both have an array of objects and they scale them. So it makes sense to put the common functionality in a parent, the container, and put only the differences in the child classes. And then the parent has a set items, so the viewport can set the items in its parent, and let the container do all the things that it should do. Of course, the container does need to know how to scale because that's different from the viewport and the splitter. So we had a method for that and implemented in both the viewport and the splitter. And that's how you get to the usable code. One thing to note is that this is the class hierarchy. But there's a different hierarchy, and that is the object hierarchy. So once you make construction of the classes for your scaling, then you have an object hierarchy in your diagram, and it uses the class hierarchy. Just to note, because sometimes this causes confusion when you begin object orientation. Questions yet? No? So let's add some interaction. So the first thing I want to do is add a way to show or hide parts of the object hierarchy. So we do that simply by giving each object a label. It's a string label, and then implement the method show height label, and we can call a VI that goes over the hierarchy, and when the label matches, it shows or hides the object. The container is a little bit more difficult than the object because the object is simply a match. But then the container actually has to go over all the children. And once you have this, basically it goes automatically over the entire hierarchy and shows or hides objects. Yeah, so I used regular expressions. I'm not sure who uses regular expressions, but they're pretty fantastic. This enables me to say, hey, I want to hide everything that starts with an A, or anything that contains a letter or a number. That immediately adds so much more flexibility to a library. But that's off topic. Yeah, let's demo that. So this one got the applause first time, so high expectations. Let's run this. So what I do is I initialize the objects and put them in the viewport. I don't have splitters here. And then in a while loop I basically say, hey, I want to hide and one of them, and then do the update by the resize. And when you run, you can something like this. Yeah, no, this will be a pulse at the end. You won't make it otherwise, time-wise. Of course, I use the continuously run button now to do the update continuously. Of course, you want to do this on a panel resize, and the bounds should be the pane content over here, not a random rectangle. But the way it's set up is you actually can do it manually, so you can give a manual rectangle that comes for anything. So that's basically just flexibility. I could have made this a pane reference, but then you lose that flexibility. So I like to keep my libraries open so you can do funky stuff if you want. I have no idea what you would want, but why narrow it down? Pane resize, the same thing as the panel resize. You need to implement both because those are different events, and on both events you need to resize. And then this little trick here makes sure that while you are resizing pane, it doesn't continuously start updating. The update isn't that fast. So what you will typically see is once you wiggle the pane, it starts lagging, and 20 seconds later it will still be catching up with all the size resizing. So this trick, the old bounds and the new bounds will always be the same for once when you're done resizing. That makes sense? So you resize, and when you're done resizing, you will get one event where the old bounds and the new bounds will be the same. And that's when you resize. The single instance of
the event. So there's a checkbox on the event.
Yeah.
Limit to a single instance so that you don't have that problem.
I'm not sure if that option is available for the pane size.
Yeah, I can do both.
Yeah.
2017 has it for sure.
Yeah,
So you still get like repeated, so that means it executes once, but then the next time the loop comes around and you're still resizing the pane, you get another. It means that you can only do one and two at a time, right? But it still executes repeatedly.
yeah, you can, but
And also, like, it's nice because as you're resizing, you have to kind of show maybe, like,
you might
I
want.
mean, I do it because of that exact same problem. You're doing that and you're resizing. I mean, it's the same thing as when you're programmatically doing Anyway,
I'm pretty sure I explored those options like flush the queue and limit the events, but I think this works best for me. You can experiment with it. So eventually we can make child classes or options and have both options depending on what you want. So more interaction would be the resizing of the pane. We didn't cover that. We just had a splitter that splits statically. So we make a new child under a container because an interactive splitter is a container. It just has to, or this is the trick to make the interaction and the dynamic panes. That is by making on mouse move event, and then when you get a mouse move event, you go over the entire hierarchy. See, there's a hit splitter. If the mouse hits a splitter, and then when there is a splitter hit, what I do is I show a subpanel, and the subpanel will have a splitter in it, either horizontal or vertical. And when you move it, you generate an event. And when you get an event, you resize the pane. So like this. In the interaction class, I have an init. It starts splitter VIs. And then on the mouse move, it goes over all the hits, hit detection. So it goes over the positions of the panes that you have. It sees it, the mouse hit the splitter, and it will show the splitter VI in the subpanel. And that's all handled by the class, so you can all hide it in there, and the user doesn't have to be bothered by that. When the splitter is done, it will actually, the interaction will export a user event. When it's done, it will generate the event, and you can do the resizing. Is that clear? It's not that easy, but it's also, yeah.
So your splitter VI doesn't actually need to have an actual splitter in any of the because it's a self-evident splitter, whatever.
Yeah, so the question is, the splitter doesn't need to be a splitter. It doesn't. It is in this setup, but you can change it.
Because one of the things splitters they small.
Yeah.
Sometimes they
Yeah, so the splitter cannot be small in LabVIEW, but in this setup you don't even have a splitter on your front panel. So the objects can actually overlap their pane, extend their pane. So you can have two objects like this and have the pane in the middle. It doesn't matter because there is no splitter. Actually, that is what I do in this in my application. I make the graphs bigger because I don't care about the borders, and I want the intensity graph itself to maximize its size, so I don't have loose space. So they actually overlap their panes, and the Duke doesn't care. I mean, you.
I should just define an area where each of the
Yeah. Yeah. So that will be another benefit over traditional panes. You can actually overlap stuff. So decoupling. As for now, we put all the events in the main VI. In an event structure, of course, you don't want that. If you have to use this library and every time you use it, you have to add all those events to your main event, you don't want that. So I made a class for it, of course. An interaction class by reference. And it basically contains an interaction only in the DVR. And that way I can, in that class, start a dynamic VI and it handles all the events. So you don't have to do that in your main VI. Some user events are created to enable the interaction, but this one is important. It just starts sort of a daemon-like API, and it does all the handling. More similar stuff going on here. Details. But what we have done is the last demo. Looks like this. So we initialize objects, put them in viewports, put them in splitters. Over here we nest the splitters, so I have two vertical splitters and put them in a horizontal splitter. And everything is labeled. And this VI handles all the events, all the normal scaling. I still have an event structure, but it handles the key down. And it also gets an event just to demonstrate how you would get the interaction with the daemon VI. So on key down, I show and hide stuff. And I can now say, hey, I want graphs to show or hide. This one is fixed actually, so it has a limited size, so it won't resize even if there's space. But I can also hide the entire top level, bottom level.
You're just hitting keys?
I'm hitting keys, yeah, so the top row is A, so when I press A, the top row is hidden. When I do Control A, it shows again. There are also splitters between there. So yeah, so I can manually resize. Perfectly manually. I can still hide them, and when I show them, they will come back. Yes?
Why did you decide to have your splitters take an array of objects rather than just two? Do you see like having more than two splitters in there?
Yeah, so why do I have an array and not just two inputs? This top splitter has 3 elements.
So you can, okay, so you can have multiple splitters.
Yeah.
Multiple splitters in a single.
Yeah, you can have a page split in 3. Yeah. That was actually the reason that I needed a viewport. Because I didn't have a viewport, I could just say, hey, put an array of objects in the left and an array of objects in the right. But that doesn't scale up to more than 2. Because then you would get a 2D array and it doesn't work. So you make a container that contains them and you have an array of containers and that works very well. Some afterthoughts. I think this is shock. This is the hierarchy for my application that I showed at the beginning. So yeah, this is a mess, you could say, but it's also very to the point. You can read it like, hey, I have an interaction that handles all the splitting. I have a splitter vertically, and then I have all my top stuff over here, all my bottom stuff over here. So yeah, do you need to make something to make this prettier? I'm not sure. It is what it is. I mean, even fitting stuff on one screen, if something is a sequence and it's a long sequence, why not have two diagrams with a sequence? I mean, you can make sub-VIs and fit it on one VI, but you're only obfuscating stuff. You could do this all by name, right? You can VI server this and get the names and the sizes, and then you would have a string that automatically makes this. XML comes to mind. I mean, it's all sky's the limit. Just to notice, this plays nice with subpanels. I now use booleans and graphs. You can also use subpanels and have dynamic content, as Derick showed in there. So let this toolkit do the scaling and this toolkit do the content of the or MGI or whatever. This also works with Active Framework or DQMH. It doesn't really matter.
Question for you. Like when you're resizing the buttons or any front panel code for that matter, or things like graphs, have you done any work to try to figure out how to manage the actual text itself, like the font sizing, so that you don't go too small and
No.
font or board?
No. So the question is, do I handle font sizes? No, I don't. First of all, that's very hard. It's a very hard
That's
problem.
why I asked.
Yeah. I think if you do want to do that automatically, this would be a good starting point. If you extend it to also these size fonts. The second reason is that some fonts cannot be changed. I think skill labels of graphs, for instance, they don't have a property to change their fonts dynamically. So it's just not possible to have that. You could, of course, switch between a large font graph and a small font graph.
And I'm thinking not so much on graphs, because they do scale generally well enough. It's like buttons, right? Like you want a button, you want the text to be big and bold and show that whole
Yeah. Okay. Yeah.
And you want to shrink it, then you're losing your text.
Yeah. If there are properties to change it, you could maybe even inherit from what I have and extend that functionality.
Or any guideline, make sure that it doesn't shrink beyond what would be.
Yeah, there is a minimum shrinkage, and I think it even graphs, if you make them too small, they get corrupted, and there's no reset skill layout method. So I think it actually hides graphs when they grow smaller than 10. We do something similar with buttons, like if it grows too small, replace it with another button. It's not in there now. Yeah, there's other features, hit detection, so you can say, hey, I have a coordinate, which pane is that coordinate in? You can query visibility, just saying, hey, is this pane hidden or is this regular expression hidden, stuff like that. The bottom one is interesting because that's actually something that my customer wants. Store save the layout so that when you reopen, the sizing is persistent. It's actually working for the general library, but not for my application, so it's not. I could probably put it in there, but it's not done for me. So, yep. So this is the URL. You can get over here. It is donationware, so lots of people have donated. 0. So. But still just you always have you can always argue, should I sell this, should I give it away? Selling only makes sense if you could sell this for 2,000 euros or something, or dollars, because the overhead of the sell is so high, you won't make any money otherwise. And nobody's going to pay 2,000 euros for this, so you might as well make it free. Don't have any required support, stuff like that. So yeah, but if people like it, yeah, at least they can pay me if they want to. Maybe buy me a beer and then do it for the PayPal or something. It's an experiment. This exact same presentation is also recorded at GDEFO. Which is European, what do you call it, independent G conference. This year will be the second time it's given. I hear rumors that there will be an American one also. So yeah, that's cool stuff. Check it out. This video is also recorded. Derek's also. So it will be online eventually also. So yeah, any questions? So yeah, all the way in the back.
Have you given any consideration to maybe a pane that has an aspect ratio that needs to be checked? Keeping that in there so that it resizes but it keeps an aspect ratio?
So the question is, did I make a pane that keeps its aspect ratio? The panes themselves keep their ratio when you scale them, but you mean vertically horizontal ratio?
Yes.
No. Could be possible. It could be very hard because I don't know how exactly that will work. I'm sure if it's feasible, it's easy to make. But I don't know how that would work.
The application showed that you moved the bar up to 3 graphs on the top.
Yeah.
Move this way and else.
Yeah, exactly. So my executable that I showed actually did that. The graphs keep their ratio, but that was just the plot area. So I do that manually afterwards. So when the paint scale, I get an event and I can say, hey, this is the new sizing of my graphs, and I adjust the aspect ratio manually. Yeah, good notice. That's sharp. More questions? Okay. Well, you can.